I don't know what to do with that. It just seems you must be able to do something smart with it. Anyway, so these are some things they played around with. Email, air transportation, some just circuitry, E. coli data. And they're able to do some pretty reasonable things. So you'll see a lot of the examples I'll show you, people have worked in ways that they know what the answer will be, which is fine, and then they look at things that, of course, we don't know straight away. So this is airline flights, and we know, of course, they're regional, right? So you're going to reproduce the structure of countries, geography. And there's real hierarchy in here, right? So there's these major blobs. I can't tell you which ones they are offhand, but this is one of these will be Europe and the United States, and maybe Asia, right? And then Australia is probably this tiny one, and then but there are links across them, right? So this will be trips between, I don't know, maybe it's the US and Europe. And then it goes in and in. So there is a, they're sort of getting out 1, 2, 3, 4, 5 layers of hierarchy. It's pretty good. Just to sort of say again, this is part of a massive effort to find the structures of systems, right? Massive effort. And these are just some sort of important things that people have tried. Some are slow, some are fast. But all of them are trying to get to this. Well, some of them are actually getting some different pieces. Right, because what we're seeing here is efforts to get things out by really presupposing they're hierarchical. If they're not hierarchical, and I'll get to an example of that later on, then you're in trouble. So this is E. coli. You can see it's messier, right? It doesn't have quite as great an outcome. And you could probably get to this from lots of different approaches. You should be able to. It should be close. And then it becomes a question of speed and all those sorts of things.